We have just deleted 3 files from working directory, staged those changes and committed them. And we have created third commit. In my case, SHA-1 hash of this commit is here. And we did it still on a master branch. At the moment there are no changes, and that means that all 3 areas are consistent. I mean working directory, staging area and Git repository. Let's first have a look at the list of commits. Git log. Enter. And now we see 3 commits. Here is first commit. Here. Next comes second commit. Here it is. And last one commit is here. Here is SHA-1 hash. Author, it's again me. And date of this commit, along with time zone. Here you see still same pointer. Head points to master branch. And that proves all what we have discussed in the previous lectures. Current branch tracks all new commits, and pointer of the current branch moves automatically to the last commit. Let's have a look at contents of the head file. Let's close this and let's cut .git/head. Enter. And here we see contents of the head file. And contents remain unchanged. Here we still see reference to refs/heads/master file. And if I'll have a look at this file, let's copy this and cut .git, make sure to add .git folder here, because we allocated in first project folder, then slash and paste copied path. Let's press enter, and now here I see new SHA-1 hash, and that is a SHA-1 hash of new commit. It starts with A8 to C, and if I'll again look at git log command, you see this SHA-1 hash here as well. And this again proves that pointer for current branch master has changed automatically, and now it points to last third commit. Let's now use git cut file command in order to read contents of our last commit. Git cut file -p, and here let me copy few several characters like this, paste here and press enter. And here we see contents of last third commit. Here is pointer to new tree object. Here is pointer to parent commit. Here are author and committer, same person, and commit message, third commit. Notice that this commit has pointer to parent commit. That's because this commit isn't the first commit in our project, and I have told you that all further commits must have pointer to at least one parent commit. Later on in the course you'll see that commit may have pointers to multiple parents. Okay, great. That's our contents of last commit object. Let's have a look at contents of this new tree object. Git cut file -p, and here let's paste several characters of this tree SHA-1 hash object. Copy, paste, enter, and here we see nothing, empty output. But if I look at the type of this object, instead of -p I'll use -t, enter, I'll see that it is tree object. But why contents of this object are empty? Please try to answer this question yourself. Answer is pretty simple. We have deleted all 3 files from working directory. Our project is now empty, and that's why this tree object doesn't have any links to any blobs or other trees. And in order to simplify understanding of those changes, I have outlined them in this diagram. So, here is third commit, and it points to this tree. But this tree is empty, it doesn't have any links to any blobs. Why? Because we have deleted all 3 files. Now our working directory is simply empty. If I'll go to it, you'll see only hidden.git folder, no files at all. And that's why again tree object is empty as well. Here again you see our last third commit. It has pointer to parent commit, again timeline is here. Here is first commit, second commit and third commit. And we can say that second commit is child of the first commit and third commit is child of second commit. Master branch points to last third commit, and this pointer was changed automatically. And certainly head has moved along with master branch. It still simply points to refs/heads/master file, nothing else. That is a picture of our project now. Let me show you one more thing. Let's go to terminal and let's examine contents of staging area now. Git ls files -s. Enter, and we see nothing. That's because there are no files in staging area now as well. Working directory and staging area are now consistent. There are no files here and no files here. But there are still files, old files in Git repository. And if I'll go to Finder, go to .git folder and open objects folder here, I'll still see bunch of folders here inside. Only two of them were created today, this one and this one. Inside of this folder, Git has created three objects, this one that starts with for B82. And in your case, SHA-1 hash for this tree object must match with mine, because contents of this tree object are the same. It's empty tree. And another file was created in my case in folder A8. And here Git has created commit object. In your case, this folder and file name will be different because of different SHA-1 hash of third commit. In my case, SHA-1 hash of this last third commit is here, A82C and so on. Please note that all previous files and folders are still in place. And that means that Git stores entire history. All previous trees and blobs are still in Git repository. And we will be able pretty easy and fast go to previous commits and check out previous trees and get access to the files that were actually deleted by last commit. I mean file1.txt, file2.txt and file3.txt. Please observe changes in your repository on your computer, and only when it will become fully clear to you, please move on. In the next lecture, we will try to travel in time and go to previous commits, commit 1 and commit 2. I'll see you in the next lecture. Bye bye.